Well, let's take a look at the next section, section 1.2, and the I can statement. And our goal for today is I can multiply and divide integers. So we're going to write the word integers here. And we'll talk a little bit later about what integers are and remind yourself. Hopefully you've got that memorized at this point. But we're going to start with a little warm-up, and you want to make sure that you're prepared to discuss these answers and explain them to somebody. If you need to use a number line for any of these things, that would be just fine. So the first question is, and all of these I think can be found in our explanation for yesterday's material. So negative means a particular word, and whenever we talk about a negative, we're also going to be using the word opposite a lot. So we're going to write the word opposite here. And then question B, why is the absolute value of a number always positive? So you're going to want to think of what the definition of absolute value is. And it refers to distance. So the reason absolute value of a number is always positive is because distance is always positive. All right, let's take a look at the next one. We're going to find each of the following. We've got some absolute value problems here. So remember, these vertical bars mean absolute value. So this is asking for the absolute value of 14, and this is asking for the absolute value of negative 28. And again, absolute value refers to distance from 0. So the question here is, how far is 14 from 0? So if we had a little number line and 0 was here and 14 was here, it would be 14 units away from 0. So we'd say the absolute value of that one is 14. And negative 28 would be way down here. And it doesn't matter which direction it is, it just matters how far. So this is going to be positive 28. It's just referring to the distance that it is from 0. And then remember what additive inverse is. That's going to be the number that we add to make it equal to 0. It's going to be the opposite of that number. It's going to undo, like adding 7 or whatever. So the opposite of that, or the additive inverse, would be negative 7. It says what's the additive inverse of negative 10? So that's going to be the opposite of negative 10. So that's going to be positive 10. And then, like I said before, what are the integers? Hopefully you've got this memorized by now. Integers are the positive and negative whole numbers. And I'm going to write the word whole, but I'm going to use, hopefully everybody's okay with a hashtag here, positive and negative whole numbers, including one other thing that we sometimes forget, including 0. So keep that in mind. Integers are positive and negative whole numbers, including 0. And then again, that's a good working definition, so we get all the pieces in there. And let's be careful with each one of these right here. This one says, what is the opposite of owing $5? So what is the opposite of owing $5? Well, that would be having $5 that you don't have to pay anybody. What is the opposite of negative 5? So this is kind of like the questions that we had up here. So the opposite of negative 5 would be positive 5. And again, we don't have to put a sign in front of that. We don't have to put a positive sign there. We just assume that it's positive. And it says, what is the opposite of 9? Well, that's going to be negative 9. Again, the word opposite can be interpreted as negative. And these are very similar to the questions that we had up there. So since negative means opposite, like we talked about up above, we can kind of keep that in mind to figure out how we can do multiplication and division of integers. If we put a negative in front of a number, it changes its direction from 0. So if you think of what happened with each one of these, this could be the opposite. So the opposite of negative 5, it was at negative 5, now it's at positive 5 because we did the opposite. And the opposite of 9 is negative 9. It was on the positive side, and now it's on the negative side. So if we keep that in mind, then we can do something like this. So again, I'm going to put 0 right here, and we're going to start off with this number right here. I'm going to put 5 over here, so I'm going to put the number 5 right here. Put a little tiny dot right there so we know where it is. Okay, and then this means the opposite of 5. Well, like we talked about up above, the opposite of 5 is negative 5. So what it's going to do is it's going to change its direction from 0. So it was over here at positive 5. Now it's going to go to the left. So negative 5 is right here. So I'm going to put a big dot right here on that one. And then we're going to start off with negative 8 right here. So negative 8 is over here. Okay, I'm going to put a little dot right there. And this is the opposite of negative 8. So the opposite of negative 8 is going to be positive 8. Okay, so if we're over here at negative 8, the opposite of negative 8 would be positive 8, and it would turn out over here. So it's going to be positive 8. Okay, now we're going to talk about implied multiplication. And hopefully you've heard of that. If not, we're going to describe what that is. But we use implied multiplication a lot once we get past elementary school, and you're going to see a whole bunch of that today. So using the idea that negative means opposite, so go ahead and write the word opposite here. That's going to help us understand the rules for multiplication and division of integers. So I've got a couple different ways to represent this. I've got multiplication right here, and I've got this in symbols, and I've got the same thing with division, but we're also going to talk about if you tend to think of things kind of verbally and in words, we've got a way to deal with that as well. So if I have a positive times a positive, if I multiply those together, we end up with a positive answer. If we have a positive times a negative, we end up with a negative. And if we have a negative times a positive, we end up with a negative. And if we have a negative times a negative, we end up with a positive. Now, I told you we'd talk about implied multiplication. This right here is implied multiplication. A lot of times we'll use a dot for multiplication. We might use an X in elementary school for multiplication. But the most efficient way that we can do multiplication once we get to 7th grade and beyond and start working with algebra and that sort of thing is we actually use implied multiplication. So if there's nothing in between the two symbols or the two numbers, we assume that that's multiplication. So we start off with a positive. There's nothing here that changes it to the opposite. So we've got a positive times a positive is a positive. Positive times a negative, there's that opposite. So the opposite of that positive is going to be negative. We've got a negative times a positive, that's a negative. We start out negative. This doesn't change the direction. This doesn't do the opposite of that, so that's still negative. And the negative times a negative is a positive. So we start out negative, and then we do the opposite of negative, which would be positive. So I'm going to run through here and we're going to talk about the verbal phrases that can help us remember it. So basically we're saying that a positive times a positive is a positive. So we'll write positive in here. A positive times a negative is a negative. A negative times a positive, if we reverse that order, it's not going to change the answer, so that's also going to be negative. And then if we have a negative times a negative, then we end up with a positive. Now, what I'd like you to take a look at is, that's kind of like what we did up here. This was a negative times a positive, so we ended up with a negative. This was a negative times a negative, so we ended up with a positive. Now what's cool about this is the rules for division work exactly the same way. So if we have a positive divided by a positive, we end up with a positive. If we have a positive divided by a negative, we end up with a negative. If we have a negative divided by a positive, we end up with a negative. And a negative divided by a negative ends up being a positive. So we're going to do a couple of examples right here, and then we'll do a bunch of practice as we do the assignments and that sort of thing. So I'm going to shrink this down just a tad so that we can see the rules right here. And again, this is what we're talking about with implied multiplication. This is where we're going to see things most of the time. And one thing that you can do that's helpful is you can kind of compartmentalize. And when we compartmentalize, we break things up into smaller problems. So the first thing I want to do is, you'll notice that we've got a 5 and a 4 here. We are going to be multiplying those together, and if we multiply those together we get a 20, and we can figure out the sign of the answer and the number for the answer separately. So let's do the sign first. This doesn't have anything in front, so it's positive. So this is a positive 5 times a negative 4. So a positive times a negative is a negative. And 5 times 4 is 20, so the answer on this one is negative 20. So I'm just going to circle that. Occasionally we'll see things like this. We'll see a multiplication problem written with an X like this. Symbol you may be familiar with from elementary school. So this is a positive 8 and this is a positive 10. So when we multiply those together, we're going to end up with a positive. I'm not quite sure what that's doing there. Okay, but I'll go ahead and get rid of that. So that's going to be positive. And then we've got 8 times 10, that's going to be 80. Now it's important to keep in mind that we don't have to write the sign in front of a number if it's positive. So I'm just going to go ahead and write that down as an 80. And then over here we've got a negative times a positive. You'll notice that there's nothing in front of that 4 except for that dot, and as you know that dot means multiplication. So we've got a negative times a positive, so the answer is going to be negative. And then we've got, let's see, 2 times 4 is going to be 8. So our answer is negative 8. Again, we've got implied multiplication here, nothing in between here, 1 in parentheses and that sort of thing. In this one they happen to be both in parentheses on example A. But on example D we've just got a 3 and then a set of parentheses and a negative 7. So we've got a positive times a negative, so the answer is going to be negative. And then we've got a 3 times 7, so we get 21 there, so we're going to circle that one. We've got division represented right here with a fraction bar, and that's the way we're going to want to represent it most of the time. So please keep that in mind and use that horizontal fraction bar. Try not to write things like this, negative 15 and then a slanted fraction bar with a negative 5. That tends to lead to problems, so try not to do that. We're going to use this horizontal fraction bar, and we're going to think a negative divided by a negative. That's our example right here. Negative divided by a negative is a positive. Now I could write that plus sign, or I could just know, okay, I'm only going to write down the sign if it's negative. So if I want to write down the plus sign, I'm okay. If I wanted to erase that and just say, okay, I know the answer is going to be positive, and then 15 divided by 5 is going to be 3. So the answer is positive 3. Now you'll notice that this one uses that horizontal line with the 2 dots, one above, one below. We know that from elementary school. That means division. We don't use this very often, but you will see it occasionally. Again, we're going to be relying on this horizontal fraction bar like we've got in these other examples here. But in either case, we've got a negative divided by a positive. This is a negative 12 and this is a positive 3. So this is going to be negative divided by a positive is negative, and then 12 divided by 3 is 4, so the answer on that one's negative 4. And here we've got another division problem. We've got 70 divided by 10. Now I'm sure you're familiar with this, but the cool thing about this now is because we know how to deal with integers, positive and negative whole numbers including 0, this is understood to be a positive 70 divided by a positive 10 and a positive divided by a positive, just like we had up here. The answer is going to be positive, so I'm not going to write that. And then I've just got 70 divided by 10 is going to be 7, so I go ahead and circle that answer. And then here I've got, we'll do the number first on this one. We've got a 22 divided by 2, so the answer is 11. And here's why I recommend figuring out the sign first. A lot of times once somebody writes down a number, they think they're done and they just move on. This is not the right answer for this one because we've got a positive divided by a negative. Positive divided by a negative, right here, the answer should be negative. So the answer is negative 11, not positive 11. So you've got to make sure that you're careful with that. Now we're just about done for today, and we'll turn you loose and you can probably do a couple of these as practice. But what I want you to think about on this one right here is, can you explain why the rules of multiplication work the way they do? And if you keep in mind what the negative means, what the word negative means, it might be helpful in figuring out how the rules of multiplication work and how the rules of division work and why they work exactly the same way. Well, let's just summarize this. The bottom line is we keep the sign of the original number unless we multiply or divide by a negative. And if we multiply or divide by a negative, then we use the opposite sign. In other words, we go the opposite direction. Let me make that look just a little bit better there. Okay, we go the opposite direction because that's what negative means. So if we go back up here and we take a look at each one of these, this starts out as positive, and then we multiply it by a negative. Well, the opposite of positive is negative, so the answer is going to be negative. Starts out positive, gets multiplied by a positive, so there's no opposite in there at all. That's why we end up still staying positive. This one starts out negative. It gets multiplied by a positive. There's no opposite in there, so it stays that same direction, stays that same negative direction. This one starts out positive. It gets multiplied by a negative. So that's the opposite of positive, so we end up with a negative answer here. Same type of thing here. Let's think about division. Starts out negative. We're going to divide it by a negative, so the sign is going to be the opposite of what it used to be. If it started out as negative, the opposite of that would be a positive, and that's why the answer is positive. And then the last thing I want to do is just remind you of a couple vocabulary words. So what does the word product mean in math, and what does the word quotient mean in math? So if you think about that for just a second, hopefully these words come back. Product means multiply, and quotient means divide. And sometimes we'll say the quotient is the answer to a division problem and the product is the answer to a multiplication problem. So it's used kind of interchangeably there, but remember, product means multiplication and quotient means division, or the answer to a division, answer to a multiplication problem. All right, you can go ahead and get started on the homework, and we're going to do part 2 on this next. Thanks.